Hey, life science. One of the organ systems that we haven't talked about yet is the nervous system. And I think it's only fair that since you're learning all this stuff with your nervous system, we should at least learn about your nervous system. So, one of the ways that we can learn about the nervous system is by learning about your senses. And one of the ways that you can learn about your senses is by breaking them. And I don't mean we're going to damage anything, I mean that we're going to give your senses some information that it has trouble understanding so we can test its limits and get a good idea of how they work. So, under here, I'm going to lay down some colors. Of course, we all know our colors: red, orange, moving through the rainbow. Past yellow just a bit, there's a greenish yellow, a deeper green, a kind of bluish green, nice light blue, a darker blue heading towards violet, which is finally here. And, just because it's in the set, here's a kind of like a burgundy color. And finally, a black marker. Well, with all these colors that our eyes can see, we can actually learn how your eye sees color. Turns out that your eye can only see one color, even though there's numerous colors for you to see. Your eyes can see red, green, and blue. Those are the three colors that your eyes can see. Well, if you can see just these three colors, then how are these in-between colors possible? Well, here's how this works. You have some pigments in your eye called cones. Oh, they're structures containing pigment. And these pigments are sensitive to these three colors, so that you have red cones, which are mostly stimulated by red light and will tell your brain that they see red. Green cones that are mostly stimulated by green light and will tell your brain that they see green. And then blue cones that are mostly stimulated by blue light and will tell your brain that they see blue. If you're looking at something in an in-between color, what does your brain hear? If you're looking at this, your green cones say, I see green. Your blue cones say, I see blue. So your brain says, I guess it's blue-green. Similarly, if you see both red and green in equal amounts, your brain says, I see yellow. If it's slightly on the red side, it will show as orange, and if it's slightly on the green side, it will show as this kind of greenish yellow color. Same thing with violet. If your eyes see red and blue, in other words, no green, then your brain is going to see this. Now, this is something that you can demonstrate in real life, but not being able to do that presently, we can approximate that effect with some digital effects. So here's what I'm going to do. I'm going to simulate the effect of being in a closed-off room with no windows and no lights except a single color which we can shine. And this is what it would look like if only a red light were shining. If only a red light were shining, this red marker, this cap still looks red, everything is fine, but the white part of it is hard to distinguish from the red now. On the other hand, colors like blue and green, which used to look colorful, now are just the colors gone. In fact, they look quite dark. Okay, let's change the color from red to green. Now that only a green light is on, the red which was visible before is now just, it's dark. Red and especially violet, but blue as well, should be pretty dark because there is no green light in those colors. The only green that you can see anymore is this which was originally green and this which was mostly green, but also everything that used to appear white now appears green. Why does the white turn to whatever color the light is? Well, the reason is like this. The white light that is shining on these markers ordinarily has all of these colors in it. So when that white light shines onto, say, a green marker, the green marker absorbs the red and blue and reflects the green. That's why your eyes get green light from it, because it reflected it rather than absorbed it. Well, the white is reflecting all of it, which means if you send red, green, and blue light onto the white spot, it will give them all back and you'll see white. However, if you only give green to it, it will just give the green back and it will look green to you. Well, we stopped one color short. Let's see what it looks like when it's just a blue light. When it's just a blue light, as you might expect, the things that were blue still look blue. Everything that is or was white now looks blue, and everything that had no blue in it now looks dark. Okay, let's try a couple secondary colors. This time it's going to be more like what if only one color was off. So let's start again with red. Instead of only having red on, let's have only red be off. This is what it looks like when the only lights are green and blue. Everything that was red is now dark, but every other color is just showing the degree to which it was bluish or greenish. As well, all of what used to be white now shows blue-green. Okay, now let's try just turning green off. Everything should look kind of violet or magenta, as only red and blue light is coming off of anything in this picture. Okay, last of all, let's just have the blue off. Now, everything that we see should look kind of yellowish. And the reason that it looks yellowish is because everything is just giving us red or green, or both at the same time. Okay, so what I'm going to do now is I'm going to scramble these markers and have a new light arrangement, and it's going to be up to you to try to tell which marker is which. And I want to remind you what the options are: red, orange, yellow, green, green, blue, green, blue, dark blue, violet, burgundy, black. Okay, so these get scrambled, the light changes, and we'll see what is where. Okay, the only light shining here is red. Can you identify the markers in order from left to right? Pause the video, write down which ones you think they are, and then resume and see if you're right. White light back on, you can see what everything was and check your answers. Let's do it again. This time though, I guess we'll do just green light. So scrambling the markers again, with these all mixed up in a new arrangement. Go ahead and pause it, see if you can write down the correct order of markers, and then when you're ready, resume and see if you're correct. Alright, let's get that white light on. You can check to see if you are correct with the markers. We'll do this one more time, but with blue. So, scrambling the markers. Going to lay them down in a new order. Blue light only this time. Write down your guess as to which marker is where. Resume the video after you've made your guesses. Okay, white light back on. You can see where the markers are, and you know whether you got it right. Well, we've done the primary colors. Let's try the secondary ones now. If only the red light is off, are you able to tell which marker is where? I'm going to lay them out. Red light is off. You just have blue and green lights to go off of. Resuming the video with white light, you can see where everything is. Same deal, we're going to just have the green lights off now. So we're going to mix these up. I'm going to lay these down with just the green lights off, red and blue on. See if you can determine the location of every marker here. Back on with the white light, you can see where every marker is. Last up, we're going to just have the blue off. Red and green will be the only lights on. We're only going to be seeing with blue and red lights. I'm sorry, with green and red lights. Blue is off. Have a look, see if you can tell the order in which these markers are laid. And after you've made your guesses, you can resume the video and check. And with the white light back on, you can see where everything is. This is a very strange experience when you're doing it in real life, in a darkened room with a colored light. I understand that we're kind of used to visual effects and things looking unusual on a screen. I kid you not, this is what it looks like in real life, and it's very disconcerting. So now that we've established kind of how your color vision works, I want to move to another sense. This time it's going to be your hearing. Now, with vision, you're able to tell a lot of things. For example, you're able to tell where something is in relation to you. You're also able to do that with hearing. And the way that you're able to do that is by your brain putting together and comparing what each ear is hearing. If there were a sound right there, it will be louder in this ear than in that one. Not only that, but the sound will reach this ear first and this ear last as it travels across my face. What this means is my brain has two different levels of information on which to judge where that sound is coming from. We can actually test this by messing with your ears and feeding them misleading information. So here's what you need to do for this next part. It's absolutely essential that you listen to this with headphones. If you don't listen to it with headphones, it won't have any effect on you whatsoever. So make sure that you're listening to this on headphones now. Now that you're on headphones, the exact same sound is coming into each of your ears. You are hearing the same thing in your left ear and in your right ear. Now, according to all of your experience, if you hear something the same in both ears, it's because the source of that sound is right in front of you. After all, when you're talking to someone face to face, your ears are both open to that sound right in front of you. They're both the same distance, and that means that both ears are getting roughly the same information. What I'm going to do now is play you a series of sounds that have been changed so that they should appear to be coming from different directions. Now, once more, I want you to write down your predicted answer before moving on to the next one. Where do you think this sound is coming from? You can write your answer as if it is a direction pointed away from you or a verbal description of the location. If we were doing this in a classroom, I would just have you point. Where do you think this sound is coming from? Where do you think this sound is coming from? Where do you think this sound is coming from? Where do you think this sound is coming from? Now, I have to admit, on a couple of those, I was cheating. For example, in this sound, this is an impossible situation in real life. You see, when something is producing sound, it vibrates, and it causes those disturbances in the air that we call sound waves. So just imagine something pushing back and forth, causing the air to ripple out in front of it. That's what your ears capture and register as sound. Well, in this sound, what you're hearing is this ear is hearing push-pull, but this ear is hearing pull-push. That is actually impossible because the same sound source cannot simultaneously be pushing and pulling so that each ear is receiving conflicting information. This is a situation which doesn't match real life, and so, never having experienced it before, your brain has no idea what's going on and probably gave you a very confusing answer. As for this one, once again, I'm tricking your brain. You see, whenever an object makes sound in real life, even though your ears are receiving slightly different sound due to the time and distance differences, at the very least, the nature of the sound it's receiving is the same. In this particular case, that's not true. You see, all you need to do is very carefully attempt to recreate the same sound, though each of them is a different event. You can think of it as two separate performances of the same song by an expert musician. They can be very, very close, but they can never get it exactly the same. So even though they sound similar, your two ears are actually hearing two different things that happened at different times. Your brain is able to pick up on these subtle differences enough to not be able to make sense of where it's coming from, but not so much that it's fooled into thinking that it might be the same sound. So when it tries to come up with where is it, it actually kind of gives you an answer. It's just an incorrect one. It sounds like it's coming from everywhere. This is actually taken advantage of in music production. There's an effect that you can put on things called a chorus. And what a chorus does is it disturbs the spatial recognition information that we get from sound, and it tends to make something sound like it has multiple sources. In other words, like a whole bunch of singers in a chorus. Anyway, just knowing about these things is really very enjoyable when you see them being used creatively in art or in music, but it's also just a lot of fun to get inside your own head and mess with it just a bit. Anyway, that's the nervous system, and I hope you found this enjoyable. Oh, wait. One more thing. I can't forget about this. There's another way to demonstrate how your eyes work. Here's what I want you to do, okay? I'm gonna be a ghost for a second. So here I am on screen. It's just me. We're gonna have a staring contest. Now, in about 20 seconds of staring at me, the screen is gonna go white, and then you're going to have a negative image of me. And let me explain how that works, and then we'll do it. You see, from this part of my face, your brain is receiving some red, some green, some blue, but mostly red and slightly more green. That's what gives me this skin tone. Down here, however, this shirt is mostly blue, although with some red and some green. This part of me is kind of a mix of all of it, maybe slightly more on the reddish and greenish. Anyway, when you stare at the same thing over time, your cones can become exhausted. They can become saturated. And in order to prevent them from getting permanently strained, your brain will actually shut them down and just say, okay, I know, I was seeing red there. You don't have to keep telling me. But what happens is, when the image goes away, your brain is still expecting red to be there. So when the red disappears, it's getting less red than it was expecting, and therefore your brain interprets that to be red light off, and it shows you blue-green instead. Anyway, here comes the staring contest. This is how we'll end it. Just stare at me for a good 20 seconds, and then after that time, the screen will go white, and you'll see a reverse image of me, and then we'll be done. Ready? And go.
He's a ghost.